So this is question 1d. Again, it's another derivative problem. The first thing we do when we look at this derivative problem is we just kind of want to note this terminology here where they say where c is a constant. Anytime they use that type of terminology right there, that means treat whatever that letter is as a number. So I always say treat it like a 5. So whatever you would do to a 5 in a derivative problem, you would do to that c. So the first thing we want to do here is really kind of clean this thing up. So they're giving us the cosine of c times t to the 5th minus 3c. So what I really mean by clean this up is I want to get rid of these parentheses on the inside. So I'm going to distribute this c in to both pieces here. And what that's going to do for me, put my equals in there, r of t is now going to equal the cosine of c times t squared, so distributing that c through there, minus, and then c times 3c is going to give us 3c squared. So this is now my brand new math problem, and what it allows me to see is that I'm really looking at a chain rule right now. So anytime I've got a function inside a function or something inside something, in this situation I've got a cosine equation here with this c t squared minus 3c squared inside it. So anytime you've sort of got the cosine of something inside like that, you're going to be looking at a chain rule. And so my chain rule saying is d in times d out. So the derivative of the inside piece times the derivative of the outside piece. So what I mean by that, what I would call the inside piece would be this chunk right here, because all of that stuff is inside the cosine function. So I would call my in piece would be the ct squared minus 3c squared. My outside piece right now is just going to be this cosine. So the outside piece is just the cosine of a bunch of junk. And so we're really just going to leave that junk alone. It doesn't affect us when we're taking the derivative of the outside piece. So going back and looking at these now as two smaller bite-sized chunks and trying to find my d in and my d out. The derivative of the inside, the d in here. So again, this c is just a number. It's like a 5 or a 2 sitting out in front right there. So you just want to treat it like that. So this is really just going to be a power rule. I'm going to bring this 2 down in front and multiply it by that c. So I'll get 2c t, and then subtracting 1 from the power of 2 right there leaves us with the first power. And then this back end here, this is all just a number. That's just a big constant right there. And so even though it's got that c in there, because c is being treated like a constant, it's being treated like any other number. So really what we're looking at is just a number, just a constant, and the derivative of a constant is always 0. So that piece is just going to cancel out entirely. So our d in was really just this one power rule set up at the very front here. The d out right now, the derivative of the outside, is really just a special case derivative for cosine. So cosine is a special case situation. You just have to have it memorized what the derivative is. So if f of x equals the cosine of x, then the derivative of cosine of x is going to equal negative sine x. Again, that's just a special case. That's a rule you have to have memorized. If you have it memorized, super easy. If you don't, then it's kind of hard. So taking the derivative of the outside piece here, we're really just taking the derivative of cosine, which we said was negative sine, and then we're going to leave all the stuff alone that was on the inside of our problem already. So that was our ct squared minus 3c squared. So now that we have all of our pieces, we've got our d in, we've got our d out, we can really come back over here and start putting together our derivative, our r prime of t. So we were running everybody through the chain rule, and so the chain rule says d in times d out. So we take the derivative of the inside piece, that would be 2ct going on there, and we're going to multiply that by the derivative of the outside piece. And so the d out would be this piece right here. Whenever you're doing this, make sure you put this parentheses up in front there, or else they'll read that negative sign in the front of sign as a minus, and they'll happily ding you a point. So just make sure you put all this stuff in parentheses. And so negative sign, and then ct squared minus 3c squared, left all that stuff alone. So in the end, that'll be our final derivative. It's really just identifying what your primary rule is, getting your saying down, then labeling your pieces and taking their derivatives, and then we just put it all back together into our saying, d in times d out.